Hello, everybody. My name is Jose Villeda, and I'm here to talk to you all about my project, which is titled Elevation Drives Leaf Nitrogen in the Guadalupe Mountains National Park. So, a big introduction to all of this is that plants employ different strategies, and it's important because they center around how an individual plant performs. So that might include their survival, their growth, their reproductive success, everything that's specific to an individual species. And these strategies can also be affected by factors like natural selection and climate change. Stuff like that is in the environment in which these plants are found. And these strategies can be determined by many factors. And I've used this simple equation to be very visual to y'all. And I made it to where plant strategy equals life history plus environment factors. And these are the two factors that I worked with and to see if they determine strategy. And plants strategies can be defined along a slow continuum. That's how you kind of quantify them and are allowed and can place them along to see uh, where a species belongs, whether it is a slow species where it's slow growing, long lived, and it could be like a giant sequoia, or it could be something simple as like a flower, which is fast growing and a short lived species. And this continuum has many trade offs. For example, individuals in lower resource environments might not want to utilize fast traits. They might use slow traits because it's disadvantageous to have these fast traits in a lower resource environment. And it's the opposite way. In a high resource environment, you would see plants with fast strategies and those traits that put them on the side of fast. And looking back at this equation, one can say that functional traits define strategy. And combining these two equations that I've already talked about, we can replace strategy into the second part to where it's strategy equals life history plus environment, and instead putting functional traits equals life history plus environment. And this is we hope to see what, or at least I hope to see in this project, how functional traits can allow us to determine the drivers of plant strategies, and those two being defined by either life history traits or environmental factors. Some of the two specific defining factors that I looked into were woodiness specifically for the life history traits and elevation for the environmental factor. And the functional trait that we use to for this project was the leaf carbon nitrogen ratio. And I'll talk about these specific defining factors one at a time. First, I'll talk about elevation. So elevation gradients, or the factor, can alter the environment in which a plant grows in and can define its strategy, perhaps. And along an elevation gradient, there's different light intensities, different temperatures, atmospheric pressure, and water availability. And a combination of these can alter what kind of plant strategy a plant will employ in the given environment. The second trait, or the second defining factor that I looked into, was woodiness, plant woodiness. Woodiness represents a life history strategy, and it's reflective of investment in either support, defense, and structure. This is at the expense of investment in other things, such as reproduction. And lastly, the functional trait that we used was leaf carbon nitrogen ratio. And what that is, it's the mass of carbon to the mass of nitrogen found in the leaf of plants. So for example, a low carbon nitrogen ratio would indicate faster growth and reproduction, and this would be the opposite in high carbon nitrogen ratios. Some of the goals that I had for my project was to use this functional trait that I was talking about, the carbon nitrogen ratio, to see if I'm able to quantify the drivers of plant strategies within the species that we sampled or had samples from, which were from the Guadalupe Mountains National Park. And the hypotheses that I came up with separately with each defining factor was for woodiness, that leaf carbon nitrogen ratios would be lower in herbaceous species than woody species because the need for greater enzymatic production to promote faster growth and time to reproduction in the herbaceous species. And for the elevation, which is the environmental factor, I said that leaf carbon nitrogen ratios would decrease with increasing elevation because the light level goes up and atmospheric pressure goes down. And the samples that we had were a collection of samples from the 1970s, and we weren't able to have all the samples in this specific project because of the time restraint, but with that time restraint, we were able to have 53 total samples, which came from 13 different families, which included stuff like forbs, trees, shrubs, and grasses. And the map on the right kind of shows you kind of where in the area you can it's found. And the species were categorized as not just necessarily annuals or perennials, but as either what type of plant function they were. So if there were C3 plants, C4 plants, C3 grasses, C4 grasses, for the woodiness aspect of this project. And we were also able to have the elevation measurements included. But with the samples that we got, we rolled them up and to foil balls so that we could put them in the elemental analyzer that kind of helped us, or that helped us get the carbon nitrogen ratios in them. And some of our results included that percent leaf nitrogen increased with elevation, and you can see that overall increase in our data or our results. And the opposite was that leaf carbon nitrogen decreases with elevation. And this is similar to the finding of leaf percent nitrogen because it's just the inverse, with the nitrogen being at the denominator of the ratio. So these two findings go hand in hand, and it was our defining result within this project. As far as the woodiness of the plants, there wasn't really any significant effect. On average, the herbaceous species have more nitrogen in their leaves, but this difference is not statistically significant. So we go back to this equation that we were talking about at the very beginning and seeing that if the functional trait is defined by woodiness and elevation, because we weren't able to find any significant findings for woodiness in our project, the functional trait specific to what we were looking at was not defined by woodiness. Instead, it was defined by elevation. So at GUMO, elevation is a primary determinant of plant strategies. Elevation was what was driving the plant strategies in this environment. alone, or one of the primary drivers or determinants. And we can go back to this idea of strategy equals life history plus environment. Since environments are constantly changing, and we found in our research that that's what was the factor that was controlling the strategy, it's important to know how, like, the environment is changing, whether it's climate change, urbanization, and other factors. Being able to quantify life strategies through fast slow continuum also can help us understand the continuing evolution, abundance, and distribution of species in a given environment. And lastly, there's other factors that we could have gone into to test along with elevation, because with elevation, increasing elevation, there's also differences in temperature, and plants are very responsive to elevation. It gets colder up the mountain, and signatures of climate change is species are moving up mountains, and climate changes is making them move up further, perhaps. But to directly observe these patterns, something that was a possibility was to have future resampling of these species, because these species were collected in the 1970s and 50 years have passed. So perhaps if this is a driving factor determinant for the plant strategies, it'd be a great idea to hopefully in the future compare the carbon nitrogen ratios to see the responses and the differences. And these are the references that I used for a lot of this project, a lot of background information and research. And I'd like to thank the Honors College Undergraduate Research Scholars Program for supporting this project, especially CH and Helen Jones Foundation. And lastly, I'd like to thank Evan Porowski and George Ochoa for helping me with sampling and presentation preparation. Thank you guys so much.